So do that one. All right. This I can close. All right. So this week, again, you should be rereading chapter 3 if you haven't. Make sure you understand, extremely familiar with if else, and switch. Remember the three different types of can't even think code structures, and this little thing here. I told you that story, right? The one about object oriented programming and that. No? Yes?
I don't think.
Okay. Well, again, so if you have, then tell me once I get going here. So anyway, procedural programming has been around a long time. Okay, we need it. You know, you need sequential. You need to be able to make decisions. You need repetition. But back probably in the late '70s, early '80s, um, Steve Jobs was out driving around in California, and he was up by Palo Alto, and he saw a building, and it said Xerox Park on it. So it was PARC, which is Palo Alto Research Center. And so he had just made his first several $1,000,000. He was on the front of Time magazine and some other stuff. They'd moved out of his parents' garage, Apple had, and that. And so he stopped in, and a young lady answers the door or shows up in the foyer, whatever. I don't remember her name. I know she had red hair. But anyway, he
You're
goes,
breaking up.
I can hear him fine.
okay.
Same.
I also missed a few seconds of that.
Okay. So Jobs is out driving around. He comes to this place called Park. Okay. PARK or PARC, Palo Alto Research Center. And it's owned by Xerox, okay, which is the copier company that is in New York. And the deal with Park was that back in the day, it was said that 40 of the smartest minds in computer science worked at Park. Okay. And that was pretty amazing since they only ever had the most I think they ever had working there were 35 people. So it was like a think tank. Okay. And so he stops, knocks on the door. Lady comes to the door. Hey, my name's Steve Jobs. Oh, Steve Jobs. Yeah, I've heard of you. Can I come in and see what you guys do here? And so she let him in. And Jobs basically saw three things that day. The first thing he saw was that they were running an Ethernet. Okay. And if you don't know what that is, that's where you plug your computer into the network. Basically, the networking we do nowadays, they were doing back then when the rest of us were using what were called token rings that need real big cables and about yay big around. And um, unlike the Ethernet that we use today, okay, which uses like just a little bigger than telephone wire. Um, so that's one thing he saw. The next thing he saw was object oriented programming. They were doing object oriented programming back then, and that's what we do today. Okay. And the third thing they saw, which was his big thing, was they actually had computers with desktops and were using mice and icons. And up to that point, nobody had, we were still using the keyboard and a command line at that time. Nobody knew how to point and click on an icon to make a computer do anything. But Xerox PARC had figured it out. So Jobs leaves that day, and the only thing he concentrated on was that desktop, and went back to Apple and told his engineers about it. Why aren't we doing this? And they said, doing what? We don't know what a mouse is. We don't know what an icon is, blah, blah, blah. But Jobs knew at that point, if there was, if you had a bunch of geeks that had to use, back then we used, I'm trying to think here. Just the command line. You had to know how to do this. So let's see if I can get it to work here on mine. Okay, this is all you would have seen if you logged in. And so you would have had to know commands like that to get a directory, to move around. You'd have to know how to CD, and you'd have to know which one of those were programs. Like if I type, that's not going to work. Let's see here. Where was I at before? I thought that might work. Oh. Anyway, the only ones that would list or that you could use were a BAT, an EXE. I don't know if I have to on this one. It doesn't see it. But there was only 3 types of programs that would even run on your computer. The rest were directories or libraries and whatever. So you had to know all these different things, okay, to get it to work. So now with that, so Jobs goes back, tells his guys they all want to go see it. So he calls back over to the Palo Alto Research Center, asks the lady again, can we bring my guys over? And she says, no, because you're going to steal this from us. And he says, oh, okay. So he calls New York, goes over her head, and New York didn't care. They didn't even know what they had out there. You have to understand if Xerox would have realized what they were doing at Park, they could have owned the computer business. Okay, they could have owned desktop computing because they could have copyrighted using a desktop and all that kind of stuff. So anyway, he goes over their head. This long story to make it short. He goes, him and his guys go back over there, and the next thing you know, we have the Macintosh. Okay, Xerox never was a player in computing. Just they're a bunch of copier heads. The funny part of the story is that Gates, again, you have to understand back then, Apple was just a hardware company. They didn't write programs and stuff. So he needed, now that he was building the Macintosh, he needed programs for it. So where did he go, do you think? Anybody?
Did he try to contact Microsoft at one point?
Ah, hey, Bill, my buddy up in Seattle. Do you think you could write some programs for this new system we got? Well, sure. Why don't you send me? I need to know, though, how the operating system works. Steve, you shouldn't have sent him that software. So Jobs tells Microsoft how this system works, and guess what we got next? Windows, yep. So now, after he got that, took it from Xerox, then he gives it to Gates. Gates, then a few months after that, we get Windows for the PC. Apple sues Microsoft, but there was no case law at the time. Case law is just like if you ever watched the court shows where they say, according to Smith versus Brown back in 1970, blah, 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 blah. There's no case law. Nobody's ever sued anybody over a program before. So the case went on and on and on and on. And by the time it was settled, Microsoft had sold millions and millions of copies of Windows. Apple eventually did win, but the amount of money was minuscule compared to what the loss was. Anyway, and then before later in his life, Steve Jobs is kind of funny because he says, this was a quote, says, I really don't have anything against Microsoft. They just don't come up with original ideas. This from the guy who, of course, stole the idea of the desktop from Xerox. But anyway, that's kind of, the object-oriented programming thing was originally developed by, or one of the people that were developing it back then was Xerox, not the people that we have now, Microsoft or any of them. Anyway, so that's kind of that scenario, just kind of a little tidbit there of the history. You got 3 programs this week. I was looking at the lottery program is a little bit difficult in a sense. We're going to draw the card one in class today. Here's the deal on the lottery one. There's one in the book, but it's only 2 digits long. They have a lottery that, it's 2 digits. This one has to be 3 digits. And here's some of the rule. Well, after I say this, it's if you put in, so 3 digits, right? So normally in a real lottery, you can specify any numbers you want from 0 to 44 or something. I forget what it is now, but you'd specify like 5 different numbers, right? 4, 5, 6, I don't know. In this one, you're going to it's one number, but each digit, okay? So if you put in 1, 2, 3, for example, okay, if you match 1, 2, 3 exactly in that order, you win $10,000. Okay. If you match 1, 2, 3, but you match all the digits, but not in the right order. So say you have 3, 1, 2, 3, 2, 1, 2, 1, 3, you win $3,000. Okay. And then if you only match one number, let's say you type it's 1, 2, 3, and you put in 4, 1, 7. Okay. Then you only get $1,000. Or even if you put in 4, 1, 1, you get $1,000 because you didn't match all 3. So you have the perfect match when the numbers are exactly the same. You have the match of the numbers, but not in the right order. And then you have just if you match any of the numbers. Okay. Or, I mean, if the number's 1, 2, 3 and you put in 1, 1, 1, you still only get $1,000. You don't get $3,000. Okay. Because you only matched one of the numbers that was chosen. You don't get it because you matched the same number 3 times. So you guys understand that?
Yeah.
I do.
Okay. So here's another rule. I don't want you to, I'm thinking about this and we'll talk about it here real quick. If I wanted you to put the number in as, don't not put it in as type in number 1, type in number 2, type in number 3, the user I'm talking about. I wanted you to say, put in a 3-digit number. So they have to type in 1, 2, 3, 999, 555, whatever, 542. Okay, you understand that? Instead of typing in a 5, a 4, and then a 2. Since I have thought this, I came upon a problem though. And I think I'm going to let you do the 5, the 4, type them in one at a time because of where we're at in the course. If somebody picks, you're fine unless you put in 0, 8, 9 or something like that. If you lead with a 0, the system thinks it's an octagonal number or octal number, I'm sorry. And it won't work right. And I tried removing it and finagling it, and it's way above, you almost have to have a loop and you have to turn it into a string or an array, and you really have to manipulate the number. So here's my choices, I think. You can have them enter a number that has to be larger than, see, you'd have to put in a number that's at least 100. So you'd have to tell them, you have to pick a number between 100 and 999, because that one digit can't be a 0. And what else? Yeah. Because when you try to put that in, it's going to error out, I think. We'll take a look at it. I've got a partial program written. Maybe it'll do it if we use the scanner to get the number. Maybe it'll truncate it. Anyway, so that's what you got to do. So you have the 3 comparisons. Are the numbers the same? Boom. If they're the same value, they get 10,000. If you match 3 of the numbers or all 3 numbers in any order, you get 3,000. And if you match any number 1, 2, 3 times, it don't matter, you get $1,000. Okay. Any questions on that one?
No.
The second one is a lot easier than it is. This is what you got to remember. Okay. The rectangle is going to be, what is it? It's either 5 by 10 or 10 by 5. Let me look here. 323. It's one of the two. 323 points. Width of 10, height of 5. Okay. So width of 10. So if a point, first of all, I'm going to specify this. The point, the center of this, here, let me do this. I'll even put it in here for you. Okay. Note, the center of the rectangle is at 0, 0. Okay, so that means that from 0, if I have, if my x axis, it runs from -5 to 5, right? And then my height would be from -0.25, or I'm sorry, -2.5 to +2.5. So if they type in anywhere from a -5 to a 5 for their x, and if they type in anywhere from a -2 to a -2.5 to 2.5, it's the point is in the rectangle. Okay. The point is in, but if it's anything bigger than that, in other words, if they have a -6, well, that point can't be in the rectangle. Or they have a -3 or a +3 or a +5.1, it's not in the rectangle. If it's on the line, it's in the rectangle. In other words, if somebody puts in 5 and 2.5, yes, that point is in the rectangle. Okay. Any questions on that one?
Not so far.
I would expect you to allow them to put in a double for the, not just integers. Or allow them to type in, I'm sorry, whether or not it's so they can type in a double. And then the draw a card one, we're just going to do in class. All right. So let me back out of here a second though. All right. There's 2 videos. They're not that long. Okay. And I could make you sit here and watch them. I thought about doing that, just class would have been a little longer. You can see this one's 7.5. This is when I had my hair cut. But you can see here, this is, we kind of talked a little bit about the one the other day with, I wanted to pick a student out of ICC. Didn't we do that?
Yes.
So this is what it would look like in a flow chart. Okay, so I go over that again and run you through that. It's like 7 minutes long is all it is. But you should understand how this works, okay? And why you're going to pick certain things first. Oh, that's a nice picture, Doug. Why you're going to pick the class first, because it's going to, in this example, I think I had 14,100 students or something like that. Okay, so that's the first video. Get rid of that one. Get rid of that one. And then this one, I forget which one it is. Oh, I think it's an easy. And this is another one that I think we did. What? This is the one where, but I just I wrote it out for you better. Okay. And it's only 4 minutes long. So I'm not going to make you sit here and watch it right now, but you should take a look at this, especially like if you weren't here the other day when I explained it in class. Okay. So that's that. Any questions on what we're doing this week? We're just, pounding in the, excuse me, decisions and selection a little bit more. Oh, there's a little ditty on the Turing test too. So Turing test is just basically, can you tell a computer, it's either a man or a computer? That's basically it. So if you don't, you should know what a Turing test is, and if you're going to make this a career anyway. All right, let's go over here. I want to see something real quick here. Let's see something here. This will help make up my mind here. Import Java dot utility dot scanner. And then let's try, instead of me getting this here. All right. So, So this is what I want. Instead of saying enter your first number, second number, third number, I wanted basically that you just enter a 3-digit number. And then we'll do int number is equal to my scan next int. So let's see what happens here. If it in fact does it. So if I do 68. Oh my gosh, it works. Let's try this. That works. So the scanner takes care of that octal problem. All right. So I'm going to let you guys see this. Okay. Since it does now work. And this will make your life a little bit easier. And since we're in the, you should remember this, by the way, how to break down a number. And there's a couple ways to do it. This is just one of them. Okay. So this gives me my first number here. I'm a first digit, Doug. And then this one should get you your second digit. And so that's your tens, your like that, your hundreds, your tens, and your ones. So that way, so we can then, I am going to specify then that you have to have them put in a 3-digit number. I'll leave this up for a second so you can get it down. Because this chapter really isn't about breaking down digits that's coming up. It's more about the decision. Making decisions. So this will cut some time, or this should save you some time. And there's a couple, like I said, there's a couple ways to break this down, but this works good. I think it'll even work on 000 it better. Sure did. Cool.
I do kind of have a semi-silly question. How exactly does the percentage before the 10 work mathematically?
Long division.
Okay, is that what that? Okay,
Yeah.
that
So
that makes
this
more
is
sense.
this makes the remainder. So let's say you had say you had 10 parentheses 3. The answer would be 1 because that would be the remainder. It's like when you learned long division and before you knew how to do fractions, you probably did the long division thing and then you had to write down somewhere what the remainder is. Okay.
Yeah, that makes more sense.
All right. So let's say you had 12 divided by, or I'm sorry, 12 module. It's called a modulus. 12 modulus 5. Okay. The answer would be 2. Because that 5 goes into 12 2 times and then has a remainder of 2. So we're looking for the remainder. Or here's a good one. Whoever was talking, Devin.
Yeah.
Okay. So how about 12 percent sign 2 or modulus 2? 12 modulus 2, what's the remainder? Heck, really?
Talking about 0.
Yeah, okay. How about 13 modulus 2?
1.
14 modulus 2?
0.
Yeah, so I'm checking for odds and evens, right?
Yeah.
What if I had a program, I could do some count. Let's say I had a timer or something, and every time it, who's writing on the board?
Sorry, that was a mistake. I'm trying to figure out how to stop it.
I don't even know how to stop it. Let's see, how do I clear this?
I'm sorry.
I could have it do something like every time the count got to 100, because I could have count modulus 100, and every time it got to 100, it might, balloons might go up in the air. I don't know. Okay. So there's a lot of uses for modulus. Or you can say remainder, right? In other words, what is the remainder of number divided by 10? Okay. And I could have used it here too. Doesn't make much difference, right? Number modulus 100. Oh no, that would give me the remainder. That would give me this one here. Instead of subtracting here, I could have just put modulus or modular divided by 100 and then divided by 10. Oh, I'm sorry.
I'm not sure I'm getting the right number for the tens.
You should. Number, let's see here. Let me see.
Should it be a 1-digit number or a 2-digit number?
1?
Because I'm getting two-digit numbers every time.
Okay, well, let me see if mine works. I think it does. 999. Oh, now I'm getting 99. Why is that? It wasn't before.
I did the math on a calculator and it's calculating correctly. I just think like you need to like, I think you need to subtract by like,
I had my number, subtract the number of hundreds.
subtract by like 10 times whatever you get.
Oh, that's right. This should be number divided by number times 100. Is that right? Okay, 999. That came out right.
Yeah, it's working right for me now.
0, 0. That's working. Okay, so I had that. Okay, make that correction. Okay, we good with this? Everybody got it?
Mm-hmm.
All right. So let's get rid of this. Close that. All right, new project. We're in Ant and Acme draw a card or something like that. So it's project. Let me draw a card. This will be Acme draw card. And the date today is 2/8/. So I think that works. There we go. And since I'm going to put random in here, and I'm going to add an import. And the user has no input on this one at this time anyway. Okay. So 52 cards, 4 suits, 13 cards per suit. So I think I'm going to handle the suits first. Well, I'm going to create some randoms. So I got random. How about my random is equal to a new random. So then int suit is equal to next dot integer. That is there's 4 suits, right? And again, I'm not going to deal with the 0. I'm going to make that. And then this one will be int value is equal to my rand. All right. So that works. And so now we can process them. If those are inputs. All right, let's see. So if I do that, then I'm also going to do. Okay. And I think I'll use a switch for the suit. Oops. So we'll have case 1 is and you can do this without using the brace if you want to have an inline thing like this. A lot of times I put them inside the braces and put the commands underneath if it's more than one thing I'm doing. By that I mean you could do this and then put your stuff inside of there, right? But on this one, I'm just going to use this quicken. And I'm putting a space in here. See that? Because I'm going to want it to read right once we finish this. So it's close, right? Okay. And let's test it. And make sure we get all 4 of them. Of diamonds, of spades, diamonds again, spades, diamonds again, spades. Come on. Lots of diamonds and spades. Hearts. I need a clubs now. There it is. So I get all 4 of them. Okay, so that does that part. So now I think I'm going to use an if. Equal to, let's go with 1 first, I guess. Then
Is there a reason we can't do a switch for the?
I'm going to do that next. is going to be equal to um, I don't need a space there. Now, how many of you would have kept going?
Like all the way through 13.
Yeah.
Yeah, I probably would have done that. Is there a quicker way?
Mhm. Okay. Because all the other cards are what their value is from 2 through 10, right? They're not called anything else normally. It's only the ace, king, queen, and jack that are a problem. So let's see what I get if this works. 2 of spades, 9 of diamonds, 6 of hearts, 6 of spades, 8 of hearts, 6 of spades, ace of diamonds, 3 of hearts, 10 of spades, 7. I'm looking for a king or something, queen. There we go, king of diamonds. So the catch here is you shouldn't have kept going here. The problem is that you probably don't know this yet. So you can use it though now. Let's see. I don't think it'll let me just do value. It might. You think it will? So you could have done it. Well, that makes that easier. Probably because the rest of it here that's tacked on is it knows it's a string. So it makes this a string automatically. So that's why it's letting it do that. Cool. Makes it even easier, and then it would have fit into your nothing that wouldn't have been in this chapter. So not too hard, right? Once you look at it. And then this would be our output down here. And outside of that, we can put our infamous I will put in something above it too. I think I'll put that like that, and then I'll put one up here. If I put it here, line, where am I at here? Oh, I'm gonna be inside there. What the heck did I call this thing? And I can even move this over. If I put in right here, a tab, let's see where it moves that to, if it moves it into the, there. Just move a little bit and puts my output in the middle. Now, like, I forget who it was, Sammy, or who was it asked, could you do this? I could do this whole thing.
I
Um,
hadn't thought about the else statement, so
well,
it
I'm
does
going to
make
show you. It'll work.
Oh, okay.
Okay. So now I'm going to show you an alternative. We could have done it with the switch. Okay. So, you know what? I'm going to copy this before I do this, so I don't have to retype all those. Okay, now if I do that. All right, So now I could do this. I could say, all right, so now I could do, and I could say, oops. So you can just kind of figure what I'm doing here. Oops. And here's where it gets a little, okay, so if I delete that, what happened there? Oh, I know what it is. Wrong word. All right, let's see if that works. 3 of spades. 7 of spades, 4 of diamonds. Give me a higher card here. Queen of diamonds. So that seems to work. So it could be as small as this. So again, if it isn't any of these, it's got to be this one. And that's kind of what we did with the else. So it's just a matter really of preference at this. I mean, this looks pretty short and sweet here, right? Comments? again, would there have been anything wrong with continuing on here and saying case 10, case 9, 8, 7, 6, 5, 4, 3, 2? No, but it'd be kind of, you might get mad at the end when you realize you could have just did this, right? We would have had a lot more code. And, you know, that's kind of what we do with the else. When you got if, and then you got else if, else if, else if, you eliminate everything else, right? So the last one is the else. Here, if I eliminate all the other possibilities like the ace, king, queen, jack, all that's left are numeral ones, right? Or value ones. So I just make all them the default. And that's how you get it. And save yourself a lot of time. So we looked a little bit at where we're at this week. Again, trying to get a little more selection decision in. We're 3 programs. Now you got 2 only. We might do another one on Wednesday for extra credit. We might do one in class. Talked a little bit about Steve Jobs and where object-oriented programming came from. Again, the difference between object-oriented programming, procedural program, object-oriented program, excuse me, is the idea that we can take any object that you can think of, abstract objects, whatever, and we can create them ourselves. We can create all their methods and all their attributes. What does it do and what does it look like? Okay. It doesn't even have to be a real thing. But the other thing is we can create real things. In other words, we can represent a human being the way they are now, or we can make them the way they aren't. I mean, you could have 3 ears and 4 eyes if you wanted to, you know. It's up to you because you become the creator of the object. Okay. You become the creator of the object. So it's a way to describe things in the world and in outside the world. So it's a little bit different than strictly procedures. And then we'll be able to, like your parents inherited stuff from your grandparents, and then you inherit from your parents, we can do that with objects. We're able to pass those things down. In other words, we can create a person, and then from that person, we can create things like students, teachers, salespeople, construction workers, whatever we want to from that person. So that's where we're headed in the long run. Okay. Any questions over anything we talked about today?
No.
All right. Okay. Not a long class, but